The 92% logic failure. Ghost logic attacks achieved a 92% success rate last month against the hidden reasoning filters of Claude Fable 5 and Microsoft MAI Thinking 1. Unlike traditional prompt injections that attempt to trick the model into saying a specific banned word, these logic injections target the internal scratchpad, where reasoning models perform step-by-step verification. By poisoning the initial premises of a chain of thought, attackers force the model to logically conclude that a harmful action is actually a requirement for safety compliance. This bypasses nearly every output filter because the model genuinely believes its final response is the most ethical path based on the corrupted internal logic trace it just generated. The mechanism of constraint collision. A June 2026 paper from the ACL Anthology reveals why this works. Reasoning models are uniquely vulnerable to constraint collisions. When a model like GPT 5.6 Sol is forced to choose between two contradictory safety instructions, its internal representations for safety and functionality begin to overlap at the neuron level. Ghost logic exploits this by providing a prompt that looks like a legitimate debugging task but contains an embedded logical contradiction. As the model attempts to resolve this paradox in its hidden chain of thought, the safety neurons effectively desensitize, allowing the malicious payload to execute. It is the digital equivalent of an autoimmune response where the model's own reasoning engine attacks its safety guardrails. Why traditional filters fail? The failure of traditional reinforcement learning from human feedback is laid bare in the LAAF benchmarks released this week. Standard filters only look at the final token stream, but Ghost logic operates entirely in the latent space of the reasoning trace. In 1,700 adversarial trials, models that were 99% secure against surface-level jailbreaks fell to logic injections in under 4 seconds. The data shows that the more sophisticated a model's reasoning becomes, the more surface area it provides for these recursive premise traps. We are seeing a direct correlation between higher benchmark scores in math and logic and increased susceptibility to this specific class of architectural exploit. The shift to process observability. The emergence of ghost logic confirms that black box reasoning is no longer a viable security posture for enterprise AI. Because these attacks poison the process rather than the result, the industry must pivot from filtering outputs to real-time observability of the internal chain of thought. For developers and researchers, this means the era of hidden scratchpads is likely ending. We are moving toward a mandatory disclosure architecture, where the internal reasoning trace is cryptographically signed and monitored by a secondary oversight model. This creates a significant compute overhead, but is the only known defense against logic injections that weaponize a model's own consistency against itself. Watch for the August 2nd enforcement of the EU AI Act, which is expected to classify unmonitored reasoning traces as a high-risk compliance violation. Subscribe for more,